Hello students, we're moving on to chapter 4, which is about two-dimensional motion, and for the most part it's going to be about projectile motion. So to get started, let's review something about vectors. So if I have a vector v, like right here, it's going to have a horizontal and vertical component. The v sub x vector will be the horizontal component and v sub y will be vertical. So the process of finding those two components is called decomposing the vector. And so let's just quickly look at an example. So we have our vector v, and to decompose it, one method entails a horizontal reference line, which I'll draw here. So here's my horizontal reference. And one of the reference lines needs to go either through the head or the tail. So, okay, it's going, it's making contact with the tail of my vector. I need to draw a vertical reference line. So if one is touching the tail, now the other reference line touches the tip. So let's draw that one. Here we are. We're drawing a vertical reference line. And then the answer, our components, are going to be, they're going to be like this. Here's the horizontal component. I'm drawing it like this. And so that's my v sub x. And here is my vertical component. And I went too far. That's a mistake. I want to go just to the tip there, and then here it is. There is my vertical component. So v sub x and v sub y. Yeah. So in this example, when I drew the, with a ruler, pencil and ruler, when I drew it, I made this vector here to be 28 millimeters long. And so this would represent, depending on the scaling, 28 meters per second. And I drew this one here 15 millimeters long, so it's 15 meters per second. So in terms of notation, which we introduced last time in the vectors chapter, we could notate it this way. We could say that the vector v, which is the sum of the x and y components, is this. So the x component is 28 meters per second in the x hat direction, and the y component is 15 meters per second in the y hat direction. And these are unit vectors. They're vectors that have a magnitude of 1, and it, by definition, goes to the right. And so 28 times 1, it's 28. And so you end up with a vector like this, the 28 millimeters, or rather 28 meters per second to the right. And then this one is this one. Okay, so there we go. And this one was this one, like that. Okay, now just remember, our book is using x hat and y hat for unit vectors, whereas most other books actually use I hat and j hat. And also what we're going to be doing today also works in 3 dimensions, in which case we would have, for the 3rd dimension, a z hat unit vector, or other books would have a k hat unit vector. All right, so let's do a little example. Let's say that v was the velocity of a ball, in this case a baseball, and it's not flying through the air. It's going on a flat surface, a parking lot, and it's just rolling in a straight line, and it's going, it starts at x equals 0 meters and y equals negative 30 meters. So I picked these numbers to make the example a little bit more interesting. All right, so it's moving, and so it's not accelerating. So these formulas here are going to work. So the formula for x is the starting position x, x0, plus the x part of the velocity times time. And for y, it's the y starting position, y0, plus the y part of the velocity, the y component of the velocity, times time. And so here I've plugged in the numbers. So the starting x was 0, the y component, I take it back, the x component is 28 meters per second. And the y starting position is here, negative 30 meters. And the y component of the velocity is 15 meters per second. And okay, so now let's see what happens as things progress. So I made a chart here. I've got at 0 seconds, what is x? So let's look at our formula. 0 plus 28 times 0. You see t is 0. So that's why I put a 0 here, right? Because it's 0 plus 0 gives me 0. Now let's do y. So I have negative 30 plus 15 times 0. So that's going to work out to negative 30 plus 0. Oh, negative 30. All right, that's why I have negative 30 for y. All right, let's move forward in time. 1 second. So now I have 0 plus 28 times 1. Yeah, that's why I get 28 meters. How about on the y side? I'm going to have negative 30 plus 15 times 1. Well, okay, that's 15 there. So negative 30 plus 15 is negative 15. Ah, that's why I have negative 15. And I'm sure you can, see where these numbers are coming from. Now, I would like you to stop the video and figure out what the position is at 4 seconds and work that out, and 5 seconds. So stop the video and work that out for me. All right, so hopefully you got these for your x and y positions at 4 seconds and 5 seconds. So now that we've got this table filled in, let's make a graph of the location at various times. So at 0 seconds, the x is 0 and the y is negative 30. So you see, here we are. We're at, that's the first location. At time 1 second, we have x equals 28. So 10, 20, 30, okay, 28 is an x here. And y is negative 15. So negative 10, negative 20. Okay, so that's where we are at 1 second. And you go through that process and you get the location at 3 seconds, 4 seconds, and 5 seconds, like that. And sure enough, it seems to be doing what we expected it to be doing. It's rolling in a straight line. Now, this type of picture where you have the dots evenly spaced for even time increments, it tells us some interesting things, like the evenly spaced dots means the acceleration is 0, and the fact that it's going in a straight line means that it's not accelerating to the left or right either. Okay. So I do have some questions for you. What is the magnitude of the velocity. In other words, what's the speed of the baseball? And what is the direction angle of this baseball? And how far does it go in 3 seconds? So I need you to think about that. Okay, so you've been thinking about the answers to number 1, 2, and 3. Let me just show you that the answers are down here. Did you get those answers? Let's see how you get these things figured out. We're still doing review, basically, of vectors, but this is so important. Okay, so to get the speed, here's the process. You know that you have a velocity component, the x component to the right. You know that you have the vertical one here. It's not very straight. You are given that the horizontal one is 28 and the vertical one is 15. Okay, so let's put here 28 and 15. The units are meters per second, meters per second. And what you're really looking for is the length of the combined vector, which is the length of this thing here, and we can use the Pythagorean theorem. And so it's going to be the square root of 28 squared plus 15 squared. So if you want to sound professional, you would say we're adding in quadrature 28 and 15. And when you do that, you'll get the answer down below. For the direction angle, okay, so the direction angle means this angle here. What is this? Theta. And to get that, you see the trigonometry, SOHCAHTOA, and that. So tangent of theta is going to be opposite over adjacent. So it's going to be the arc tangent or the inverse tangent. So some calculators call it arctan. Some calculators call it inverse tangent of the SOHCAHTOA, opposite over the hypotenuse. Okay, and if your calculator's in degrees mode, you will get the answer I got down below. And for the third one, how far does it go? Well, you take your answer from number 1, right? And the distance you travel is the magnitude of the velocity times time. And so you're going to plug in your answer for number 1. So this plugs into V. And you're going to multiply that by 3 seconds. And you will get the answer down below. So you should have gotten those answers.